हाय फ्रेंड्स, हम यहाँ आज लैप्लास ट्रांसफॉर्म के सेकंड थ्योरम देखने वाले हैं। वो है लीनियर प्रॉपर्टी। सपोज f1 of s and f2 of s are Laplace form of f1 of t and f2 of t respectively, then Laplace transform of c1 f1 of t plus c2 f2 of t is equal to c1 Laplace transform of f1 of t plus c2 Laplace transform of f2 of t, where c1 and c2 are constant. Here c1 and c2 are constant. Then we prove the proof of theorem. We know the Laplace transforms equation. There is Laplace transform of f1 of t is equal to what is f1 of s, that is equal to their equation is integration 0 to infinity e raised to minus s f1 of t dt. There is first equation number. Then here is two Laplace transform, that is Laplace transform of f1 of t and Laplace transform of f2 of t. So second Laplace transform is Laplace transform of f2 of t is equal to f2 of s integration 0 to infinity e raised to minus st f2 of t dt. Here is equation number 2. Then we have to prove this theorem. So here LHS is equal to Laplace transform of c1 f1 of t plus c2 f2 of t. But we know Laplace transform of f1 of t and f2 of t. Then put here their equation. There is integration 0 to infinity. Laplace transform is here is c1. There is then Laplace transform of f1 of t is Laplace transform f1 of t is integration 0 to infinity e raised to minus st f1 of t dt plus c2. Then Laplace transform f of t is f2 of t is, here is equation number 2, integration 0 to infinity e raised to minus st f2 of t dt. But here in given here is where c1 and c2 are constant. So we know the properties of integration. Constant are throughout the integration. So c1 integration 0 to infinity e raised to minus st f1 of t dt plus c2 integration 0 to infinity e raised to minus st f2 of t dt. But here we know the Laplace transform f1 of t. Here Laplace transform f1 of t is integration 0 to infinity e raised to minus st f1 of t dt. Here is same. So put here LHS c1 Laplace transform of f1 of t plus c2 Laplace transform of f2 of t. So our theorem is proved. So LHS equal to RHS. So what is our theorem? Laplace transform f1 Laplace transform of c1 f1 of t plus c2 f2 of t is equal to c1 Laplace transform f1 of t plus c2 Laplace transform of f2 of t. We prove the theorem. Then in general, Laplace transform of summation of n r1 to n cr fr of t is equal to summation r1 to n cr Laplace transform of fr of t. Here is remark of Laplace second transform. Laplace second transform up to nth term. Then we have to give second topic is third theorem, that is first shifting theorem. If Laplace transform of f of t is equal to f of s, we know already. Then Laplace transform of e raised to at f of t is equal to f of s minus a. We have to prove this. So theorem is first shifting theorem. Then we have first to know Laplace transform f of t is equal to f of s. Then we have to this proof. Then proof, that is here we given Laplace transform of f of t is equal to, we know the equation, integration 0 to infinity e raised to minus st f of t is also equal to f of s. Here is e raised to minus st, here is s, so here is f of s. Then here is f of t is e raised to at. Then Laplace transform of e raised to at f of t is equal to integration 0 to infinity e raised to minus st into e raised to at, that is equal to dt here remaining dt. So this is equal to integration 0 to infinity. Here is equal base, so adding both, then s minus a, then minus s plus a t dt. Here common t, we give common t, then we simplify this, integration 0 to infinity e raised to minus in bracket s minus a t and dt. So first we say you, that is here is s, so f of s. So here is what is here, s minus a, so that is equal to f of s minus a. Then we have proved this theorem, that is there, so LHS equal to RHS. Then we prove the theorem, that is Laplace transform of e raised to at f of t is equal to f of s minus a. Then we have to prove this theorem, that is Laplace transform of e raised to at f of t is equal to f of s minus a. So then we give this theorem's remark. Here is complete proof of this theorem. Then we give then for example, that is first example of theorem is Laplace transform of t raised to n e raised to at. Here is first example, that is Laplace transform of t raised to n and e raised to at. We know Laplace transform of t raised to n, that is we know solve this formula, that is uh, gamma of n plus 1 divided by t raised to n plus 1, p raised to p or s. I say u, that is this p is equal to s. Then this is what we write replacement of s. Then e raised to here. Then Laplace transform e raised to at. What is this? E raised to at f of t. That is, we using Laplace transform e raised to at f of t. This is we using first shifting property already. Firstly, we prove this theorem, that is f of s minus a. So combine this. Laplace transform of t raised to n e raised to at is equal to gamma of n plus 1 divided by s raised to n plus 1. Laplace transform t raised to n e raised to at is equal to gamma of n plus 1 s raised to n plus 1 into f of s minus a. So gamma of n plus 1 s minus a raised to n plus 1, here is s and here is f of s, so we give here s. Then we have to find the solutions of Laplace transform of t raised to n into e raised to at is equal to gamma of n plus 1 s minus a raised to n plus 1. Then second example is Laplace transform of e raised to bt into cos of at. We know the formula of Laplace transform of cos of at, that is p divided by p square minus a square. P square minus p square plus a square. Then Laplace transform of e raised to bt f of t, that is equal to f of s p minus a. So we write Laplace transform e raised to bt cos of at, that is equal to p minus b divided by p minus b bracket square plus a square. Here is yes, not here. So here this Laplace transform depend on this. This is f of t. We know we give first shifting property, that is Laplace transform of e raised to at f of t. F of t is equal to f of s minus a. Here is function f of t is cos of at. So don't give here cos values. Here only gives this e raised to be at's values. Okay. Then third example we have to solve. Third example is Laplace transform of bt into sin at. We know Laplace transform sin at, that is sin at is a divided by p square plus a square. But we know Laplace transform bt f of t, that is f of s minus a. Then we have to solve the equation, that is Laplace transform of e raised to bt into sin at, that is equal to a divided by here is p or s. Don't confuse, p or s are both equal, both same. P minus b bracket square plus a square. This is values of Laplace transform of e raised to bt into sin of at. So thank you.